All right, so today we're going to be learning about linear regression. So sometimes in the real world we have data collected by scientists and others, and it can sometimes be fit with a line or a curve. Since we're talking about linear, we're only going to be dealing with the ones that can be fit with a line. It is important for people who use these models to know how well the data predicts what is happening in the data. This measurement is known as the correlation coefficient. It's your R value. So first we're going to talk about what the R value is and what that number tells us about our correlation. Okay, so we have two perfect numbers. If R is a -1 or a +1, both of those are perfect correlations, which means our data would fall perfectly on a straight line. If it is a perfect negative correlation, it means the data would fall perfectly on a line going down. And if it's a perfect positive, it's going to fall perfectly on a line but going up. Okay, so let's look at some more examples of these. So notice, when R is equal to 1, all of our points fall exactly on top of this line. So it's 1, so I know it's perfect. Also notice that 1 is a +1 and that line is going up, so it's a positive. Perfect and positive. Okay, on this next one, notice our points are falling perfectly on top of a line, so I know it's perfect. So no matter if it's a +1 or a -1, it's perfect. It makes a perfect line. But these are going downwards, which means it's a negative. Notice it said -1. Okay, on this next one, R is 0.89. Notice I can see the trend of the points going upwards. It's a positive. Also, this number right here is a positive number. Okay, 0.89, we know 1 is perfect. Well, 0.89 is pretty darn close to 1. Notice how these points are relatively close to this line right here. So since 0.89 is close to 1, we want to call that a strong correlation. Okay, on this next one, R is 0. Notice the points are just everywhere. I can't notice if the points are going upwards or downwards. I can't notice the trend at all. And so since R is 0, we know that is no correlation. Okay, on this next one, I know they're a little bit more spread out from the line, but I can still see that as a whole, it looks like those points are going downwards. Notice my R is a negative number, so it's a negative correlation. We know that 1 is perfect. 0.67 isn't super close to 1. I do not want to say that it's weak because I would say anything 0.5 or less would be considered weak. So it's not super strong, but I can still see the trend. So I'm going to call this one a moderate. Okay, on example 2, it says, which of the following R values would indicate a linear model with the best predictive values? So we want to pick the one that is most perfect. So remember, -1 and +1 are both perfect. So we want to pick the R value that's closest to either 1 or -1 because both of those would be perfect. So the one closest to either 1 or -1 would be this value right here, 0.94. So -0.94 is pretty close to -1. Okay, on number 3, it says, which of the following could be the R values for the data shown? Well, I can see that my trend is going upwards, which means I know it can't be a negative. I know also, because I can tell that there is a trend, that the points are going upward, I know it's not going to be 0, because that means the points would be everywhere. There would be no trend. And I know it can't be A because 1 is perfect. Notice, these points do not fall on a perfect line, so I can't pick A. So my answer is B. Okay, next thing we're going to do is we're going to figure out what is correlation versus causation. So I want you to underline this part right here. Causation sounds like cause. Okay, first, just because two variables are correlated, that does not mean that one causes the other. Causation is one thing does cause the other one. So causation. Just remember, it sounds like cause. One has to cause the other one to happen. Okay, so on this one, it says the graph below shows the relationship between the number of lemons shipped from Mexico and the U.S. highway fatality rate. Remember, that's like the death rate. The two variables show a strong negative correlation. In other words, as the number of lemons increased, the number of fatalities decreased. Okay, so I can see a trend in these points. These points are going down. But we have to ask ourselves, even though we see a strong negative correlation, can we say that this data is a causation or an association? So between these two things, does the number of lemons being imported from to the U.S. cause the number of highway fatalities to go down? So do the lemons coming in cause highway fatality to go down? No, it does not. So just because I can see a relationship does not mean that one causes the other. So that is what you call an association. I can see a trend, so I know they are associated, but one did not cause the other one to happen. Okay, before I jump into example 5, I did make a mistake. This table, I don't know how it ended up right here, but this table belongs to number 6. So this table is going to be used on this next problem. So let's do example 5, but ignore the table for now. Okay, so on example 5, it says, if you exercise, the calories burned per minute increases. A positive correlation exists because as exercise increases, the calories burned also increase. Can we say that it is a causal relationship? So does one cause the other one to happen, causation, or are they just associated? Okay, so we're talking about the amount of exercise and we're talking about the number of calories burned. So does exercise cause you to burn calories? Yes, it does. So I know that this one is a causation. One actually caused the other one to happen. Okay, on example 6, it says John's weekly earnings are a function of his total weekly sales. The chart below shows a relationship between his earnings and his sales. So here's this chart. So if John sells 100, he earns 506. If he sells 200, he earns $512. So that's what that chart is. Okay, what I do want you to do is it's whenever you have a table, X is always first, then it's Y. So I want you to label this as X and this as Y. Just good practice. Okay, and it tells me to write the equation to describe the data. Okay, so this is something new, and I'm going to give you a little half sheet with the instructions, but I'm going to walk you through it. We're going to put the data into our calculator, and it's going to give me the line of best fit. I'm going to figure out the linear regression for this data. Okay, so in your calculator, you need to do a new document, never save, and we're going to go to list and spreadsheets. Once you're in list and spreadsheets, in this A box, you need to put the letter X, and in this B box, you need to put the letter Y. After you do that, we need to input the data from our table. So we labeled sales as X, and those numbers are 100, 200, 1,000, and 1,500. Then we're going to go input our Y values. So we said that was 506, 512, 560, and 590. Always enter every single data. Please make sure you're in a box that's underneath all your data points. Okay, just stay somewhere underneath when you're finished typing them in. Okay, next on your page it tells you to press menu. Then we're going to go to statistics, stat calculations, and then linear regression option 3. Okay, this box pops up where it says X list. I need you to type in X. Beside Y list, I need you to type in Y. And then we can click OK. When you do that, it'll tell you your M value and it will tell you your B value. Okay, so I'm going to go write those down. Okay, so we're going to write the equation. Well, it told me that M was 0.06. It told me B was 500. So to write the equation, I know it's going to be Y equals 0.06x plus 500. So we have our equation. Next it says, what is the correlation coefficient for this data and what does it say about the correlation? So remember, that is your R value. So if we go back to our calculator, It tells me M, it tells me B, it tells me R squared. Remember, we don't want R squared, we want R. So I'm going to, boom, keep going down. It tells me that R is 1. So I'm going to write that down. So what does it tell us? So what does having an R value of 1 tell us? Well, remember, 1 is perfect. And it's a positive 1, so I know it's a perfect and positive correlation. So remember, all the data points would have fell exactly on top of a positive line. Okay, now we're talking about, is it a causal relationship or an association? So does one cause the other one to happen or not? So remember, we're talking about John and how much he sells compared to how much that he earns. So does the amount that John sells cause the amount he's going to earn on his paycheck? Yes. So on this one, it is a causation. Okay, D, the whole point of why we do all of this is we want to find the equation and the line of best fit so we can make predictions, okay? Well, it says if John earns $750, what were his weekly sales? So, remember over here I made you put an X and a Y. So it says if he earns $750, I know earnings are our Y value. So I know that $750 is a Y value. Okay, I want to show you something on the calculator again. Okay, so watch this. I'm going to show you something cool that it does. Okay, so you see how it gave us our M and our B, so it pretty much made the equation for us. What I'm going to do from here is I'm going to go graph it, and it will graph this equation automatically, and I'm going to show you how. Okay, so from this page, if you press Control Doc, this will pop up, and we're going to go to a graph. Okay, notice nothing is in here, but it's on F of 2, so what I want to do is I'm going to press up. When I press up, I can see it automatically put the equation in for me. And now that I can see the equation, I have to click enter so it will graph it. Okay, I graphed it, I can't see it, but no biggie. Just because you can't see it doesn't mean it's not there. What I'm going to do is I'm going to open my table. I'm going to press Control T because we're looking for 750 as a Y value. So my table, the first numbers are my X's, these are Y's. So I'm looking for 750 in the second column. So I'm going to start scrolling. Uh-oh. This is going to take me a while. I do not want to keep sitting here and scrolling until I get to 750. I'm only at 502. So yeah, no way. I'm not going to do that. So there's always more than one way to do it. So I'm going to do it by hand. I don't want to do it the calculator way. The calculator way is taking me forever. Okay, so the calculator gave me an equation. So I'm going to use that equation and solve it by hand. So this is the equation the calculator gave me. I know that my Y value is 750, so I'm going to take out Y and replace it with 750. And solve by hand. The first number I want to get rid of is this 500. Do that on both sides. So that leaves me with 250 is equal to 0.06x. The next number I want to get rid of is this 0.06. It's touching x, which means multiply. So I do the opposite and I'm going to divide. Well, 250 divided by 0.06 is 4,166.67. And I have x on the other side. So we know that if he earned $750, that his weekly sales were $4,166.67. So remember, there's always more than one way to get to your answers. Some ways are better and faster. So if one way's not working for you, try a different way. Okay, on example 7, it says the table below shows the average tuition for public colleges in the United States for the years 1985 to 1989. It says let X be the number of years since 1985. Okay, first of all, it wants to know, is this relationship causal or an association? So does one cause the other one to happen or not? So we're comparing the year with the cost per year of college. Okay, so can the year itself cause the tuition, the cost of tuition? Okay, I have a lot of people that get confused on this, okay? Yes, they are related. Yes, as the year increases, college is tending to go up as well. But the year itself, what year it is not causing the tuition to go up. Maybe the economy is, or maybe the inflation and stuff like that. Maybe the need for it, or there's a whole bunch of other things that might, but it's definitely not. It's definitely not the year that causes it. So it's just an association. Okay, so now we want to calculate the equation. So what I'm going to do is I'm going to go put this data into list and spreadsheets. So let's do it again. So I'm going to add a new document, always start new, never save, and we're going to go to list and spreadsheets. First thing we do is we put an X in the A box and we put a Y in the B box. Okay, then we input our data. Our X's are 0, 1, 2, 3, and 4. My Y's, 1386, 1536, 1651, 1726, and 1846. Okay, always get out of it. Remember, you want to be on the bottom, and it's always a good idea to double check that you typed everything in correctly. Everything looks pretty good. I'm in a box underneath. All right, so now what I'm going to do is I'm going to press Menu, Statistics, Stat Calc, Linear Regression. By X list, I put an X. By Y list, I put a Y, and then I click OK. Okay, so it gives me my M and my B. We're going to use these two numbers to write my equation. All right, so my equation will be Y equals 111X plus 1407. All right. It says, what is the R value and what does it tell us? So I'm going to have to go back to my calculator. Let's move this out the way for now. Okay, here's my R value. Don't look at R squared, look at R. So it's going to be 0.994. 3 digits is enough. So we know that R is 0.994. Well, it's not 1, so I know it's not perfect, so I'm not going to write perfect. But 0.994 is awful close to 1, so it's going to be a strong. My R value is also a positive number, so I know it's going to be a strong, positive correlation. Okay, now it tells us to use, let me see if I can make this a little bigger. It tells us to use our equation to predict the cost of tuition in the current year. Oops. Okay, well, we know X was talking about our year, so it's going to be an X value. The current year is 2019. But I don't want my X to be 2019 because right here it told me that X is the number of years since 1985. So I need to figure out how many years have gone by since 1985. So I'm going to take away 1985. And that's going to give me 34. So that's my X value. Okay, so I need to figure out when X is 34, what is my Y value? So, okay, from here, remember I'm going to go to the graph. To go to the graph, we press Control Dock. We're going to add a graph. I can't see my equation, so I'm going to click the up button. There it is. Click enter. I still can't see it. Just because I can't see it doesn't mean it's not there. Okay, so since it's an X, how about we try using trace? Remember, there's several ways to do things, so let's try using trace because trace allows you to jump to X's. Menu 5, 1. So, looks like an X. I'm going to type in my X. We know 34 years has gone by, so that's my X. I'm going to type in 34 and jump there. Well, that looks weird. Okay, this is called scientific notation, guys. If you don't know what this means, maybe this version, maybe trace is not the way for you. So we have to come up, okay, I did trace. I know this is my answer, but I don't know what that means. So let's think about a different way we can do it. So we tried trace. We don't know what that means, so what else can I use? Let's try using table. So Control T. I know our X value is 34, so under my X's, I'm going to scroll to 34. Found it. All right, well, I clearly know what this one means. So I know after 34 years have gone by since 1984, so the current year, we're predicting that college will cost $5,181 for 1 year, which is off, by the way. Much expensive, much more expensive. So based off of that linear regression line that we came up with, we made a prediction that in the current year, a year of college would cost $5,181. And that's it, guys.